So now let's discuss a simulation of the capacitors, that how they actually work in our daily lives. So here you can see a parallel plate capacitor, which is made up of two metallic plates which are parallel to each other, and here the circuit is completed and the capacitor is joined to a battery. And now I am going to charge this parallel plate capacitor. So as we know that the main role of a capacitor is to store charge and electrical energy. So what happens, first of all I am going to charge this capacitor by means of this battery, and then I will discharge this capacitor, like I will use the energy which the capacitor has stored by utilizing it to light a bulb. And I will also discuss that how the three factors will affect the capacitance of the capacitor. So let's start. For example, let's start if I increase the voltage of the battery. What happens is positive and negative charges are induced on the two plates of the capacitor. The positive electrode of the battery will induce positive charges on one plate of the capacitor, whereas the negative electrode of the battery will induce negative charges on the opposite plate of the capacitor. So as the charges are induced on the plates of the capacitor, positive plate of the capacitor is at higher potential and the negative plate of the capacitor is at lower potential. In this way, a potential difference is created between the two plates of the capacitor and an electric field is created, and it is this electric field in which electrical energy is stored in the capacitor. So in this way I can say that in the plates of the capacitor electric charges are stored, and in the electric field electrical energy is stored. And here our definition of the capacitor comes complete, that a capacitor is a device that stores both electrical energy as well as electric charges. So now let's see that what happens when I increase the area of these plates. Now it's a question that tell me that whether the capacitance will increase or decrease. So let's see what happens. I am increasing the area of these plates, and you can see that the capacitance of the capacitor is increased, and because the charges are increased on both the plates and the electric field is also increased, and definitely our capacitance of this capacitor is increased. And now again, if I decrease the area of the plates, you can see that the capacitance is decreasing. So in this way you can see that what happens if I change the area of the plates. What is the effect of changing the area of the plates on the capacitance of the capacitor? So now if I bring the area to a normal value, what is the effect of distance between the two plates on the capacitance of the capacitor? So you can tell me in the comment section. So now I am going to increase the distance between the two plates. What happens? The capacitance will decrease. As the capacitance will decrease, the charges stored on the plate of the capacitor will also decrease. So now let's discuss that I am going to decrease the distance between the two plates. What happens when I will decrease the distance between the two plates? The charges stored will increase. The electric field will also increase. Because the charges stored are increased, the capacitance will increase. So let's see this, how the capacitance is increased when we decrease the distance between the two plates. As I am decreasing the distance, capacitance is increasing. See, now the charges stored are increased and the distance is decreased. This is the effect of distance between the two plates of the capacitor on the capacitance of the capacitor. So now we have discussed the factors which affect the capacitance of the capacitor. If I bring a voltmeter here and put one electrode on the positive plate and one electrode on the negative plate, and I see that what is the value of this voltage, it is 1.5, and I am applying the voltage of 1.5 on a battery. If I decrease the voltage, the capacitance is decreasing. So let's see what happens if we decrease the distance between the plates and also increase the area of the plates. Now you can see that the capacitance is increased very much. So now you can see that how these factors are affecting the capacitance of the capacitor. So now let's suppose I have charged this capacitor fully by means of this battery. Now what I'm going to do is that I want to use this energy of the capacitor by lighting a light bulb. So here comes my another circuit. Here you can see a light bulb. There are the same capacitor with two plates. Now I'm going to charge this capacitor by increasing the voltage. As I am increasing the voltage of the battery, charges are induced on the plates of the capacitor. So because of the charges, a higher potential and lower potential is created and electric field is generated. Till now I have not attached the light bulb to the circuit. So now the capacitor is charged. It has stored its charges as well as energy. The charges are stored on the plates of the capacitor, whereas the electrical energy is stored in the electric field, which is between the plates of the capacitor. So now what happens if I attach a light bulb to the capacitor? So let's see what is happening, that the capacitor is providing energy to the light bulb and the bulb is giving us light. So now I want that more energy is stored in the capacitors. So that more energy is stored in the capacitors, I will increase the area of the plates and I will decrease the separation between the plates. Now I have more capacitance and more energy is stored in the plates of the capacitor. Now if I attach the light bulb to the capacitor, I will get more energy. So this energy which I am getting is from the capacitor. It is not from the battery. The battery is charging the capacitor and the capacitor is being discharged at the light, which is giving us light. So I'm going to attach this capacitor to the light and let's see how this capacitor will give us light energy. So see, the capacitor is being discharged into light energy. So in this way, capacitor is using the energy which it has stored to give us light energy. The battery is not attached. The full electrical energy is coming from the capacitor. Slowly the capacitor is being discharged and we are getting light. Here instead of the light I can put a fan. The fan will start moving, or any device. So in this way we have discussed that how capacitors are used in our daily life. They are present in mostly every equipment. They store charges, like first of all the capacitors are charged by using a battery, and then they are placed in the electronic circuit such as this light circuit, and they are discharged and they provide us energy. This can be electrical energy or any type of energy. So if you have any questions you can write in the comment section, and thanks for watching.